Hello everyone, myself Jyoti Chokar. So today we are going to learn very interesting concept of physics and which is almost around us and we see every day in our life, and the concept is known as motion. So whenever you are hearing the word motion, first of all the question which should arise in your mind is what is motion? How we can describe motion? What are the things which we need to describe the motion? So let's try to understand all these things. So motion. So motion can be inferred from two things. One, direct evidences, and another is indirect evidences. What does I mean by them? For example, birds flying, fish swims, even blood flows through our veins and arteries. We see the moving of leaves. All molecules, atom, planets, all are these in motion, and we can see them, we can observe them. These are the example of direct evidence. And what does I mean by indirect evidence? For example, air is in motion. Yes, you know, but you cannot see this. Then how we can say that air is in motion? So by observing the dust particles, by observing the moving of the leaves, moving of the branches, we say that the air is in the motion, and these are the example of indirect evidences. Okay, so what we can say that, that motion is the change in the position of the object with time. What is change in the we perceive from all these examples is that the motion is the change in the position of the object with time. Okay, so now motion, we can say that motion can be in straight line, circular motion, it can be rotation, it can be vibration, or it can be combination of all these. But what we are going to learn today? We will just focus, or according to our syllabus, according to our age, we will first try to understand the motion along the straight line. But before going to the straight line, let me try to explain you one thing, is that motion depends on the frames. What does I mean by that? It depends on the frames. It means that for one person, an object can be in motion, the same object can be in motion, but for the another person, that same object can be at rest. So let's try to understand this statement with an example. So let's imagine you are in a bus. Okay, you are in a bus. For you, when bus is moving, what you will observe? You will observe all the trees which are on the roadside are moving backwards. This is for you who are in the bus. You are in the bus and you are observing the trees are going backward direction. But a person, let's say your friend, is outside the bus. For that person, you and bus is moving in a motion. Yes. Now let's imagine you have a person along with you in a bus, and for that person, he himself or she herself and you are in the state of the rest. So using this example, we can say that motion depends on the initial, motion depends on the frames. So it depends in which frame you are standing right now. For you it can be in motion, but for other person it can be at rest position. Okay, so this is what all about motion in introduction way, in a physical way. Okay, let's try to move towards the quantitative way. I mean towards the numerical, how we can understand, how we calculate of some motion of an object. Okay, let's for the motion of an object along a straight line, we need to understand certain terms, and this can be understand using graphical methods, or we can understand this using these three equations. But before jumping or before running to all these three equations and graphical, we need to understand some physical quantities which are very essential for the motion. And what are these physical quantities? These are distance, displacement, speed, velocity and acceleration. And we also need to understand the type of motion which we are known as uniform motion and non-uniform motion. Let's try to describe motion using these quantities. Okay, so we can describe motion using distance and displacement. These are the two major physical quantities. Using them we can describe the motion. What are the distance? So what is the distance? Distance is the measure of path. Distance is the measure of a path of an object along a straight line. Okay, in distance we does not include any direction. So an object, whatever, for example, an object, consider start moving from a point O and finishes at point A. So what is the distance? Distance is this whole path traveled by that object. OA is the path covered. This is our distance. And as I told you that motion is the change in the position of the object with the time. So with that we have to describe one term which is called reference point here. So in motion we need to have reference point. Okay. So this reference point is that origin from where the object starts its path. This is our reference point. We can understand this reference point using an example. Also, for example, you have a school in a village which is 2 kilometers from north of railway station. Okay, so how we can explain this? So whenever we have this kind of questions, we need to make a graph which is like north, south, east, west. Let's say our railway station is here. I put railway station here, and where the school is 2 kilometers from north of railway station. So school is here after 2 kilometers. So this is our reference point. So reference point we can take reference point wherever we want. It's according to our convenience. It can be here, it can be here, it can be here. And this reference point is called the origin. What is called? It is called the origin. So what is the distance path covered from the origin to the point where we have reached? So now then, what is displacement? So in displacement, here we come with magnitude as well as with direction. Okay, so magnitude as well as direction, and we can say that the shortest path measure the measurement of the shortest path from final position to the from initial position to the final position in which the object has moved, in the direction in which object has moved, is called the displacement. So what is displacement? So displacement is final minus initial point. What do I mean? I mean that if a particle or if an object start from O, from origin, and it went to 60, let's say A is 60 kilometer, it went to A and then it come back. For him the distance covered will be 60 plus 60, which is 120 kilometer. Okay, but the displacement will be 0 because the final point is started from here and then it returned back to the same point. So what it will be? 0. So the magnitude of the distance and displacement can be same, but it need not necessary to be same. Okay, distance can need not to be necessary. Displacement need not to be necessary to same as the displacement. It can be different from displacement in terms of magnitude. It can be 0. Okay, this is what about displacement is. Now what is speed? So now what happens? You may observe that the same object may move fast and then some may move slow. For example, a bowler need to cover the same. Every bowler need to cover the same distance, but the speed of the different bowlers can be different. For example, one bowler throws the ball with the speed of 123 km per hour, and another bowler can throw the ball with the speed of 143 km per hour, but they have to cover the same distance. What does I mean by this? So it means the rate of the motion. The rate of the motion can be different or can be same for the object. So to explain the rate of the motion and to know the rate of the motion, what it is, we need to have one physical quantity, and that physical quantity is called speed, and this is rate of the motion. What do you mean by rate of the motion? Is the distance covered divided by time. Okay, and this distance by time, this is again in speed. We only concentrate on the magnitude. We do not include displacement. We concentrate on the distance divided by time, only on the magnitude. We don't consider direction. So similarly, what is velocity? Velocity is the displacement divided by time. Okay, so here in velocity, the speed with the direction. When the rate of motion of an object is considered along with its direction is called the velocity. So sometimes what happens, there is a change in acceleration. So a change in velocity. What does I mean by change in velocity? Before that, we need to understand two things. What is uniform motion and what is non-uniform motion? What is uniform motion? When an object travels equal path in equal interval of time is called the uniform motion, and that equal interval of time must be small. Okay, that is called the uniform motion. And what is non-uniform motion? The non-uniform is when the object covers unequal path in equal interval of time. This is called a non-uniform motion. So what is acceleration? So in case of uniform motion, velocity is same with equal interval of time. So the change in velocity is 0. So acceleration in this uniform motion is 0. But in case of non-uniform motion, here velocity is changing. So what is acceleration? Acceleration is change in velocity divided by time. The SI unit is meter per second square. Here meter per second. In speed, SI unit is meter per second. Now to describe the motion along the straight line, we can use the graphical method. So in graph we can present velocity and time. Time we can consider in x-axis and velocity we can consider in y-axis, and it can be described by straight line in case of uniform motion, and similarly we can do with time and distance graph. With these graph we can find three important equations which are building blocks for the motion, which we will use everywhere. These three equations will tell or will describe the motion fully describe the motion. The first equation is the relation between velocity and time. The second equation is the relation between distance and time, and third equation tells the relation between distance and velocity. So this is an overview of the motion which I can give best in 5 to 7 minutes. So thank you so much for listening all these things, and have a great day.